Okay, so we're going to use the PROC library. That's going to generate ROC curves for us. So if you don't have that package, then you need to install it first, PROC, okay, and then install it. And we then run the library, PROC. Okay. All right. What we require are these two: actual class and propensity. So that's all you. I mean, those are the two required options, and then there are some optional arguments that we can use. So let's go ahead and get started. So we say ROC, right? The actual class, all right, and then the probability. Okay. Now, if you run this, then it's going to generate ROC. So it doesn't plot anything, but it gives you the area under the curve, 0.9375. Okay. But we want to plot, so all you have to do is to say, well, plot equal to true. So you do that, then it's going to generate our plot for us. Okay. Now, you can save this information. So let's say owner.roc. Okay. If you run that, then it'll plot the ROC chart because of plot equal to true, but it also will save the plot information in owner.roc. And if you see owner.roc, it has the whole list of option output that we have, and then there is this AUC right here. So if you want to save the AUC value, if you have lots of different models that you're running, and you run each of them, you run the ROC, and we want to just gather the AUC values, then you don't say plot equal to true. Okay, run it, and then you can do owner.roc, and then you say AUC, and that will give you the AUC value, and then you capture that in a variable, and then keep building that. Okay, and now this is okay. Now the ROC curve doesn't have the AUC printed here, so if you want to have AUC printed there, then you can say print dot AUC equal to true. Now that's going to print the AUC right there. Okay. Now if you want to print the AUC in a different place than the very center, you can do that using print dot AUC dot x equal to the x coordinate, and then print dot AUC dot y equal to the y coordinate. Okay. Then say percent equal to true, run it. So you have the AUC, and if you change that to 60%, I mean 60, then it comes closer. So here specificity is what is getting plotted there. So if you say 20, then it goes further to the right. Okay. And we can control the color of the line. So if you say color equal to say blue, and you can also say LWD, line width, equal to, so you want 3, so now you will have a thicker line. And then you can say smooth equal to true, will smooth out the line like that. Okay. And you can make it compact. Okay, so because it's going from 150 to minus 50 when we really need 100 to 0. Remember, so this is plotting specificity, even though the points here plotted are, well, okay, it's using specificity as the tick labels. Okay. But what is getting plotted is sensitivity for y-axis and 1 minus specificity on the x-axis. Okay, so you must keep that in mind. And so you can make it more compact by saying par pty equal to s will make it compact. Okay, so like that. And you want to put the par back to the original at the end, so par pty equal to m. So that will put it right back to where it originally was. And if you want the tick marks to be 1 minus specificity, then you can do that by using legacy x marks. So here, because x was 20, the AUC is getting cut off, so let's put it back to 40. Okay. And so if you say legacy dot axis equal to true, so that will change the tick marks going from 0 to 100.